Stoichiometry problem time. Here we've got a reaction where we take some methyl alcohol. It's a pretty cheap alcohol to make. It's sometimes called wood alcohol. You basically take some wood chips and heat the heck out of it, and you'll get this alcohol, methanol. Single carbon, meth means one carbon. And as I say, it's a relatively inexpensive alcohol, but it's quite toxic. It's used as paint thinners and but you can't end up inhaling a lot of this stuff, or certainly not drinking it. It causes blindness. And if you bubble some carbon monoxide through it, however, you can change it into acetic acid, which is a pretty important product. Acetic acid is very useful, vinegar basically, but it's used in a lot of reactions. So you'll use up tons of this stuff industrially. So making it cheaply is important. This reaction is done under pressure, like 40 to 50 atmospheres worth of pressure and 200 degrees Celsius. These plants have got to be just amazing to be able to handle those extremes. And here we've got the reaction written. So let's see what they should expect when they take this carbon monoxide and push it into this methyl alcohol to make acetic acid. Ethanoic acid is the official name, but everybody uses this ancient Roman name. Aceto, which we still use for two carbons in it as an archaic name, but it really should be called ethanoic. So let's do the problem. We've got 22 milligrams. Okay, this is nice. We're starting with a pretty small amount, 22 thousandths of a gram. If you want to do this in grams, you can write in times 10 to the -3, but writing the M makes it a lot easier. So the first step we would do if we did this problem using an ice chart or using this little diagram, we take our 22 milligrams, and as a chemist would always do, we change this into moles. So calculator time, bring this thing up. By now you should know you can take grams and change it into moles by dividing by the molar mass. And this is nice. They give you the molar mass. You didn't have to do the addition of a carbon, 4 hydrogens, and an oxygen. And it's 32.04, and that changes it into a real amount. Forget weights. We want to know how much methanol we have in this reaction, and there it is, 0.687, rounding it to 3 significant digits, 0.687. It's not moles, it's millimoles. And again, if you'd had the times 10 to the -3, you'd have the times 10 to the -3, but writing that M is so much easier. Now, we need to get to the acetic acid. We'd have to go from the methanol to the acetic acid, and we see there's a coefficient of 1 here. Now, if you don't put a number there, we know it's a 1, and a 1 here. So all of this methanol will be changed into our acetic acid, 1-to-1 ratio, and let me get back there, and there it is, 0.687. That's an easy conversion. Had this been a 1 and a 2, we'd have to use those coefficients when we do our conversion. We'd take our 1 here and change it to double that. But we've got the moles of our acetic acid, our ethanoic acid, and we can change that into milligrams mass pretty easily, get our calculator back, and then multiply by our 60.05 grams per mole. This has got a greater molar mass because it's got a carbon and an oxygen in it. In effect, it's the sum of these two molar masses, and that'll give us our 41.2 milligrams. And let me check that I rounded off correctly. Yeah. 42 point. That really should be 2 there rather than 3, but 41.3. That's going to be close enough. So this is how we'd solve it, the traditional method, where we change grams into moles and then use these coefficients to find what we want to find. In this case, 1 and 1 is easy, and then multiply to get back to our grams. So we'd expect to get 41.3 milligrams in this reaction. Now, 50 atmospheres of pressure, exotic catalyst, and 200 degrees Celsius, and you'd hope you get this nice acetic acid and not have any of this leftover nasty methanol. Now, there's another method of doing this, which is called the factor label method. And here I've got it detailed. And basically, it's the same steps. This factor label, we know 1 mole is equal to 30.04. That's what this 32.04 grams per mole is, but we'd end up flipping it over because we want to cancel out the grams. We still have the milli, so we'll get millimoles. So we'll now end up getting our 0.687 moles. I mean, if you do this, that's our first step. Now, this is the step where you would, if you had different coefficients, let's say there's a 3 and a 5, you'd end up having the 5 moles of acetic acid and the 3 of the methanol down here. And notice we cancel out our methanol and we convert it. In fact, this is the factor label conversion method into our acetic acid. This is the conversion. And now here we've got another conversion where, because we have our 0.687 moles of now, when you cancel things out, what's left is acetic acid. And we just have to take this molar mass using the conversion chart, but in this case we've got the 60 over the 1 mole, and we'll get our same answer. We'll get our, let me see if I'll just move this around here and get it out of the way. 41.3 or 41.2 more accurately, milligrams of our ethanoic acetic acid. Done 2 ways. Done using this little diagram that I sort of like, but also this is another way that you should be used to and say, okay, I can use conversion factors to get the answer the same way. All right, 2 methods of doing stoichiometry.